Let's graph logarithmic functions. Okay, first let's talk about the steps. So we want to graph a logarithmic function. The first thing we want to do is plot the x-intercept. Now, if we have just a basic log with no transformations, the x-intercept will always be 1, 0. And that's because if we have the log of 1 base b, think about this. Actually, let's use x's and y's. It'll make things easier. So thinking through, if I have the log of 1 equals 0, and we're talking about base b, because the base doesn't necessarily matter. But we're talking about x and y. If the input, right, the argument is x, then the output, what does it equal, is y, right? Thinking about input, output here for graphing purposes. Because remember, b to the 0 equals 1. b to the 0 equals 1, thinking about exponentials. So that's why it will always be general 1, 0 for the x-intercept. Okay, so we're going to graph that first. Then we're going to find a point B1. Meaning we're going to plug in 1 for the y value, because that's here, and we're going to solve for the x, where b is just a random number. We'll find more ordered pairs as needed, and then draw the curve, remembering that the vertical asymptote, right? So when we have our axis, the vertical asymptote is at x equals 0, meaning our graph is going to look something like this. It cannot touch that vertical axis of x equals 0. Okay, so let's do this. We're going to graph f of x equals the log of x base 2. Okay, so step 1 said x-intercept, which we know to be 1, 0. Because if I plug in 1 for x, 2 to the 0 power is 1. Okay, so 1, 0. That's here. Okay, so there's my x-intercept. Now, step 2 says plug in 1 for y, for f of x. So we're going to say the log of x base 2 equals 1. Well, remember to solve logarithmics, we change them to exponentials. So I take the base 2, raise it to the first power, and that equals x. So that means x is 2. So that gives me the ordered pair of 2, 1. So right 2, up 1. Okay, now we can't really draw a curve through this point. So I'm going to pick another point, and I'm going to actually pick the point -1. So if I have the log of x base 2 equals -1, solve with the same idea. 2 to the negative first power equals x. Well, what is 2 to the negative first? Remember, negative exponent simply flips it. So x equals 1/2. So we'll have the ordered pair 1/2, -1. So 1/2 is halfway between 0 and 1 there. So 1/2, -1. Now I have a better idea of my curve. Okay. And you can also think through like, well, what if I wanted another point? What if, what would be a good point to use? Well, with a base of 2, think this through. So we would have 2 to the y equals x, right? This is the idea of 2 to the y equals x. So if I would do, I already have 2 to the first power, right? I already have a y of 1. So what if I did 2 squared? I would get 4. So my ordered pair would be 4, 2. So we can think through it different ways. So 4, 2 is also a point on our graph. Now I can draw the line through, or the curve through here. So I go this way, and this comes down. Remembering, x equals 0 is my vertical asymptote, means that black curve, as it goes to -infinity in the range, it will get closer and closer to x equals 0, but it will never touch. And that is the idea of graphing with logarithmic functions.